Hey everyone, and welcome to today's episode in the Caserta Data Intelligence webinar series. We're going to explore cloud providers and take a vendor-neutral look at which cloud provider you should choose, or even a hybrid solution, or otherwise. Today we have two excellent presenters with us. As you can see, we have Joe Caserta, who is our founding CEO. He is a best-selling author, thought leader, and speaks across the country on data and analytics. He wrote the book on data warehousing and ETL, which has become a bestseller, like I said, and an industry standard, which is used until today. We also have Brent Walter, who is a sales engineer at Caserta and a data architect. He will be discussing the more technical components of the cloud. And today, at the end of the webinar, you'll be on Cloud 9 to learn that we're giving away a $50 Amazon gift card to one lucky person who completes the very short survey at the end. And I'll remind you about that. So you'll want to stick around to the end of the webinar. A little bit of housekeeping and we'll get started. Caserta, if you guys don't already know, is a professional services firm. We are laser focused on data and analytics engagements. We help companies like yours with strategic assessments, with actionable roadmaps, validating your assumptions. We craft innovative designs and architectures and perform advanced implementations. Our teams are led by data scientists and data engineers who all share, like all of us at Caserta, a relentless dedication to solving problems. Complimentary webinars like today are meant to tell you about the latest and greatest in technologies and give you a neutral look at what you can do in your business for data and analytics. After the webinar, I will send you a recording to the email address you provided. And please, throughout the webinar, do not hesitate to ask any questions. You can ask them in the questions panel on the right, and our excellent presenters will answer them during the live Q&A at the end of the webinar. So we will start with Joe. Joe, take it away.
Sure. Thank you, Remy. Brent, you could present maybe? There we go. Okay. So just a high-level introduction of what we're going to talk about. So we're going to cover mainly three clouds. We may give some honorable mentions to some others. I know that the world is not consisting of just only three. You know, Oracle is out there with a cloud offering. IBM is out there with a cloud offering. Smaller shops are coming up to be competitive. But as far as the lion's share of the market, it is mostly all about AWS, GCP, and Azure as of this moment. So we'll spend most of our time talking about those three. And also, just to let you know, we are going to go fairly deep, but this is really a setup for another webinar that we plan to do. It may or may not actually be May 28th. We're still trying to nail down the date. But if you look at Caserta.com after this webinar, we will post a subsequent webinar that's married to this one as a two-part series where we will take technical deep dives into each one of them and give you our experience with that. And I will say that one of the reasons why we're waiting on that second webinar is we want to see what types of questions are asked in this webinar, and then we will shape the next webinar to be like very informative depending on what is desired by the audience. So we'll skip who we are because Remy just covered it. We're going to talk about kind of planning and organizing around a journey towards the cloud. Some success criteria that we've considered and our clients have considered when selecting. We're going to show you and just to be clear for everyone on the call, this is purely within the scope of building a data analytics platform. So what we're not going to cover is things like moving an ERP system to the cloud, right? That's completely out of scope for this. So we're going to talk about what is a logical architecture for a data analytics platform. And then within that architecture, we're going to show you how it might look in AWS, how it might look in GCP, how it might look in Azure, and then talk about some of the lessons learned over the last couple of years that we've had doing each one of those. And we should have time for questions and answers. We already covered this. That's fine. Well, I'm sorry. Let's go back. To the one more, Brent, please. Sorry. So yeah. So this no, not that one. Thank you. Yeah. So we are going to cover each of these major components. These just so happen to be all of our areas of expertise. But when we consider a cloud platform, how do we implement data movement? How do we implement ML and AI? How do we implement a data lake and the overall cloud architecture, metadata management? So we will cover each of these to a certain extent throughout this webinar. Okay. So in order to do any journey, we need to have a starting point and a destination. So we'll go to the next slide. And so what we like to do is we like to show like where we are in the life cycle of a cloud transformation. And a cloud transformation is not about choosing a platform. A cloud transformation is really about many different things. And this is the way we very methodically attack it and attacked it for the purposes of this webinar as well. But in general, we are a consulting firm. So what we do with our clients by clients, and also I apologize immensely if you can hear the jackhammer in the background. I am in New York City, and it's pounding away on my brain. So I hope.
Joe, we cannot hear. Your sound is crystal clear.
I hope it's not as disruptive for you as it is for me right now. So yeah. So the first thing we do is we come up with a series of use cases. So we look for all of the candidate opportunities to be able to take something, either a brand new greenfield idea or something that already exists, and re-engineering it so that it works functionally better on the cloud than if not on the cloud. Once we do that, then we try to figure out like what should the ecosystem look like? What are all the components, right? And we'll talk about that. The logical, we'll assume that we've done the first two parts, right? We've come up with the use cases and we've built a reference architecture, logical reference architecture for this webinar. And then the next step after that is now you're finally ready to say, okay, based on the requirements, based on the use cases, based on the components we think we need, what's the exact tool set that would perform the best when we compare functional capabilities to physical capabilities of a platform. After we do that, then we have to go ahead and build it and do the data integration like any other project. And then the last a piece that if you are really taking this journey, realize that this is not only a technical exercise, this is also an organizational exercise. And moving from an on-prem ecosystem to a cloud ecosystem is fundamentally different. It's the way you think about your entire environment, all of your infrastructure, the way you deal with data, the way you deal with the separation of compute and data, the way you think about how you would want to use tools and how you want to use data. It's very, very transformative. So the last part, as far as success criteria, this may actually be the most important one, even more than the technical platform, because even if you choose the best technical platform and build the best technical platform, if you don't address the culture and the organization around the technical platform, the adoption will never happen. Moving to the cloud is not one of those build it and they will come scenarios. Moving to the cloud has to be very intentional when it comes to a cultural shift within the organization to really benefit the value of moving to the cloud. Next. So how do you do that? So, whenever whenever there is some kind of change, right, where we're moving from an on-prem solution to the cloud, you need to do a few different things. And the most important thing is to remember that whenever you have change of any sort, right, you're gaining something hopefully better, but even if it's better or not, you're still losing something as well. You're losing what you know, you're losing your comfort level, your safety zone, all of these things that have gotten you to where you are in your career today and gotten your business to where it is today. And you're giving that up and you're going to try something new. You can't expect an organization to just do that, right? It's too much to ask any organization to just do that. So there needs to be a very clear change management process in place to do this cloud migration. And this should be started as early as when you are starting your use cases and your if we can go back the one slide, Brent, back. So you'll notice that the circles, they kind of go around each other, right? So we need to actually start the culture and organization, the change management, way back when we're starting the use cases and the data ecosystem architecture. You can go back forward. Because the reality is that people are much harder to change than technology. So we need to start as early in this process as possible. Define what that change is going to look like. Have a communication strategy within your organization. Think about or hire consultants to help. But you know, all of the people, the processes are going to be affected, right? All around your infrastructure, all around your data processes, all the way up to the way you interact with your customers and your business. It's all going to change if it's effective, if it's worth doing. All of those things should change. And then the bottom right-hand corner should be embedding all of this change into your culture, changing the DNA of your business to become a more cloud data focused organization. Next slide. So how do you do that? So most organizations have hundreds of systems, sometimes thousands, sometimes tens of thousands. And within those systems, there's many different functional capabilities that these systems are trying to resolve and support. So what we do is we recommend that you come up with a way of measuring what to do when, and do it very, very methodically. And there's basically two things that you need to measure in order to do this. First you need to do a functional decomposition of all of your business processes and just put them in a list, all created equal. And then each one of them, think about, if we were to move this to the cloud, let's look at the y-axis and say, what is the so what to the business? What's going to happen? What will we be able to do today that we can't do? I mean, what we'll be able to do tomorrow that we cannot do today? And then start ranking every functional capability against every other functional capability. And there's no ties. One always has to be either more or less valuable than the other. And you go through that process. And then you say, okay, if we were to move this to the cloud, what would it take technically, manpower, cost, like the feasibility of moving it? Do we have everything that we need? Do we have to buy more additional tools? And then we rate every capability one against the other. Again, no ties, so that everyone is mutually exclusive, and then across the whole spectrum of functional capabilities, they're also collectively exhaustive. So you've measured everything within your organization. So now it becomes, you plot that on a chart as we have here, and it becomes pretty apparent where to start. The things that are going to provide the most value, the most impact to the business, and the easiest to implement. Right, great place to start. So the top right-hand quadrant of the matrix, and then you just work your way down and to the right, to the left. Sorry. down and to the left. And that builds out a roadmap, which is illustrated on the next slide. So then we start figuring out, okay, when do we want to call it done, right? And that is like changes from organization to organization. Sometimes it's 2 weeks, sometimes it's 2 years. Usually it's somewhere in the middle. Typically, we like to aim for 3 or 4 months. 3 or 4 months, anything less than that is probably going to be a redo. Anything more than that is too long to make your business wait. So 3 or 4 months is typically the sweet spot, with some like very quick wins along the way, small wins along the way, just to show progress. 2-week sprints over a course of a couple of months, and then the next goal is to figure out, okay, in that time frame, if we go back one, Brent, sorry. Then we have to figure out, okay, how much of these functional capabilities can we fit in this first iteration of the cloud transformation? And maybe it'll just be one of them, maybe it'll be 10 of them. Like that's up to, it's never the same. It really depends on your specific scenario, your situation. Go back, please. Right, and then you daisy chain them out based on your resource capability, capacity. One thing that's very different, typically, maybe you're already doing it on-prem, but typically part of the transformation is going from a kind of a waterfall deployment approach to continuous deployment, continuous integration approach. That's usually not done right out of the gate. We recommend that if you're not already doing that, don't do it on your first iteration of your cloud transformation. Moving and re-engineering, getting everybody internally skilled, that's all enough, right? It's a lot of work. It's a lot to ask of your existing resources. We recommend do it from a project management perspective, the way you're used to doing it. After that's settled and you have your foundation built and you have your first few iterations built, then you can start doing your continuous integration, continuous deployment methods. And Brent will talk in a few slides about, even if you're not physically doing a CI/CD approach, we do want to build it logically so you have the components ready, already baked into your architecture when you're ready to start using that approach. And that's it for this slide. So now we'll talk about, okay, so now we figured out like how to attack it. Now when we attack it, we're going to figure out what's the criteria that you should use when you're figuring out which one of the vendors to choose. Take it away, Brent.
Sure, thanks, Joe. So you will have noticed on the slide that there was a sneaky little S that came in on the end there. I think by the end of this presentation, you will be very much of the mind that there are a lot of different, that there are a lot of similarities across the cloud vendors. Not only are there a lot of similarities, but there are also differences that you might want to take advantage of, because there are strengths and weaknesses for each of the vendors. So what I'm going to be doing in this section is I'm going to take us through a process for how we might go about selecting an ideal cloud vendor. And where we start is with design. We then move into mapping against the cloud services that we think that we're going to use, and then we go through a process of evaluating the services from different clouds to figure out the best fit for us. Now, the example that I'm going to be using is going to assume a fairly greenfields situation. So we're not on the cloud yet. We're looking at how we're going to do that and what we're going to use and how we're going to facilitate our solution. So we start with a logical solution architecture, and this particular architecture is for passenger experiences inside of an airport. And what we're trying to do here is achieve a situation where passengers are able to have a personalized travel experience all the way through their journey in our airport. And so we've got some, we've defined here some functional areas of the architecture. So we talk about the way that passengers move. We talk about their interactions with vendors inside of the airport. So that's commerce. We talk about the experience that the passenger has at the airport. So how they navigate around the airport. And we talk about the passenger themselves, right? So the traveler and what they need to move through the process. So we have these sort of concepts that we can talk about, and then we define ourselves some zones around services that the platform needs to provide in order to facilitate these experiences and these capabilities. So here we've got a predictive AI and ML layer, which is going to be going to sit on top of a data analysis platform. That data analysis platform is going to be collecting data both in real time and in batch. And most of the time, it's going to be taking the real time and transferring it over to batch as well. Over into sort of static lake, and that'll enable us to react to events that are happening in real time inside of our facility, and we're going to be able to go back and do historical analysis later on. And what's interesting about this particular architecture is that we need to consider the levels of trust and the levels of security that need to be applied at the different parts of the solution, because we have some parts that we'll want our vendors to access, but we've got other parts that really only the airport or national security authorities might want to access. So once we've mapped out our solution, once we kind of understand what the moving parts are, we can start going through a process of mapping these components to specific services on the cloud. And this is what this might look like for AWS. So we see that, I'm sorry that the icons, if you're not familiar with the icons, I'll walk through a couple of them. But you can see that to facilitate our APIs, we're going to run those on Kubernetes engine inside of AWS. We're going to make heavy use of Kinesis in order to collect our real-time events and to analyze those events. And we're going to make heavy use of our object store. And I'm going to go through these technologies in a couple of slides. So this is what the solution would look like for AWS. So we've got our bucket of services for AWS. But let's imagine that we haven't made up our minds about what cloud we're going to go to. So we could go and do the same thing for Azure. We can go and look at what Azure's facilities are for object storage. In this case, it's Azure Data Lake Services Generation 2. We can look at what they have available for streaming services, and we can look at the facilities that they've got to enable our data scientists to interact with data once we've got it in the environment. We can also look at services, the AI type services that the platform provides. So in the case of Microsoft, all of that, it comes under the umbrella of what they call their cognitive services. And again, our solution is still resting on Kubernetes, but this time sitting inside of the Azure service. And finally, we can do exactly the same thing with GCP, but we end up with a lot more icons in this case, which might give a hint as to where this solution best sits. So here we're using Kubernetes engine, again in GCP's environment. We've discovered that Google has a whole bunch of AI services that we want to take advantage of, particularly image recognition services and video processing services. We've also discovered that GCP provides a database that is purpose-built for two databases that are purpose-built for exactly the kind of situation that we want. So here, Bigtable will ingest all of our streaming data, regardless of where it's coming from, and it's capable of doing that at high speed and at volume, and that we can read back off of that information in real time as we need it. We're going to be storing our data in Google Cloud Storage, and we're going to be using BigQuery to interrogate that data once it's in our lake storage. Now, interestingly, with this solution, we've also got the ability to deploy Kubernetes on premise using Google's Anthos service. So now that we've got all of those components, and now that we've done a bit of a mix and match with each of the service providers, we're able to go through a process where we can look at our specific use cases. Be they order here, we'll just imagine that this is the order of importance that we want to look at them, and we can evaluate how well each of the services that we've mapped, or the collections of services that satisfy those use cases, performs for each one of the cloud providers. And by evaluate, I don't mean that we need to go through and do POCs. That would be pretty wasteful at this stage. What we can do is we can look at the service characteristics, so we can take into account service level. We can look at how responsive the services are. We can look at the volume limits and quotas. Are they going to meet our needs? Are we going to need to branch out? Are we going to need to reach out to the cloud provider themselves and sort of say, hey, you don't have the service that we're looking for, would you be interested in building it? So in this case, when we go through and we fill out our highly sophisticated Harvey balls, we find in this case that GCP is our preferred solution here. But we can also see that we probably have a pretty viable solution on AWS and on Azure, but it may not have all of the characteristics, or all of the characteristics that we're looking for. So now I'm going to go through a couple of other examples of this. So I've got a slide that's out of place, so apologies for that. So now I'm going to go through a couple of examples of other clients and other selection processes that that yield different results when we sit down and when we look at our requirements carefully. So in the case of a healthcare client, we can see that again, there's a lot of good stuff across all of we can look across our use cases, and we can look across the service providers, and we can see that all of them have a lot of really good facilities for us. But because we're in a healthcare environment, we know that security and access control are super important to us, and we need to be really granular about that. We need to have things like row level and label level, row and column level control to access our data in the environment. And so considerations like that might be more highly weighted when you are going through a process like this, and that might lead you to a different vendor. In this case, Azure is what we felt was best for this particular client, primarily because of its really granular security controls, and what that enables us to do for things like dynamic data masking of data, and applying policies at the table level to control who is able to read that data. And I'll get into some of the capabilities of the platforms in a moment.
I'll just add one thing before you change slides. So
Sure.
it's important that for your particular scenario, the categorizations of the measurement may be different, and also more importantly, they're not all created equal. And so this kind of a three-step process. So first step is to figure out what it is you want to measure, what's important to you. Second step is weighting the importance of each one of them. And then the third one is go ahead and measure it for each cloud platform. Because if you really look closely here, GCP and Azure are actually a tie. And if this were a startup, like an e-com, GCP probably would have won. But since cost effectiveness was weighted lower than the security and access control for this particular healthcare client, Azure one.
That's right. Yeah, and thanks for that, Joe. That is really important to note. The examples that we're walking through here are specific to specific use cases for specific clients. That shouldn't be read that this cloud provider is always better at biomedical computing than the other two cloud providers. That is certainly not the representation that we're making here. Moving on, here is another example, this time drawn from a financial services client. And here you can see that the winner was AWS. And the reason for that was that when we sat down with the client and when we worked through the client's requirements, we discovered that what they were really looking for was a way to integrate or to rapidly integrate alternative data into their environment, and that they were also interested in having a really stable idea of the costs that they would be incurring month to month. And so that led us down a path of recommending Redshift, which has a different pricing strategy to Azure's data warehouse and to GCP's data warehouse, that conformed with the client's expectations around how they wanted to manage costs in their environment. But this client was also taken by the ability of Redshift Spectrum to get in and read the data that didn't yet have a schema applied to it, and just be able to pull that out from the lake, and to be able to start querying that in a fairly performant way. And then finally, we've got one other example here, which is drawn from the ad tech world. And here, what would have driven this decision was the ability of GCP's advanced capabilities around video processing that would enable us to achieve real-time virtual advertising. So that would be during a broadcast, for example, being able to process the context of what's going on inside of the game, being inside of the sporting match, being able to keep an eye on what's going on Twitter, and in real time for different markets, changing what would appear on the billboards in the background of sporting events as they're broadcast to people either across the internet or on services like ESPN. So now I'm going to walk through the cloud data ecosystem. And what I mean by the cloud data ecosystem is, pardon me, what I mean by the cloud data ecosystem are the components that we tend to find clients are most interested in when it comes to building out data and analytics solutions. So the first thing that we look for is scalable distributed storage, and this is the object store, and this is really fundamental for anything that you do on the cloud. And there are some differences for sure between the three. Between the three vendors, there are slightly different performance characteristics, slightly different pricing models, and slightly different security models that sit over the top. We then sort of look for pluggable compute, and what we mean by that is a compute that can be provisioned on demand to achieve specific aims. So these are configurations of machines that are built out with specific jobs in mind. And what's interesting across the three vendors is that while AWS breaks this out into 4 different services, Azure combines them all into one service, and GCP says that you really only need the 2. We then find that the next most important, and this is really what most people get excited about when we move to cloud, we look at what the primary data warehouse service is for the vendor. For AWS, we have the choice of Redshift and Redshift Spectrum. Redshift is a more traditional massive parallel database, that is always up and that you're always paying for so long as it's up. Spectrum is an alternative backend for the Redshift for the Redshift front end that enables it to read off data directly from the data lake. And it's got some really interesting integrations with Amazon's newer lake formation service. On Azure, there's a product called Synapse Analytics, which was formerly known as Azure SQL Data Warehouse. And what's interesting about Synapse Analytics is that once upon a time, the Azure Data Warehouse service behaved a lot like Redshift in the sense that you had to bring up a cluster of compute nodes, and that you would sit there and you would sort of and those compute nodes would be up, and you would be charged for those compute nodes for as long as the cluster itself was turned on, whether or not somebody was running queries. The Azure Data Warehouse, the Synapse Analytics is actually in the process of beta testing a more serverless approach, which is the approach that BigQuery uses, which is where unless you're running queries, you're not paying for the service. We then look across services for data streaming. So on AWS, we have Kinesis, Azure Stream, and on GCP, we've got PubSub. We then dive in and look at the kind of interfaces that are provisioned out of the box for completing tasks around data science. And here, all of the vendors have some offerings. Now, one area that clients moving to the cloud are always concerned about is data security and data security capabilities. And here there is a bit of difference between the vendors. Before I talk through this, what I do want to stress is that there are often ways of achieving the same objective or the same target configuration state across all three of the cloud providers. The difference is in the approach that you take and some of the design decisions that you take along the way. But functionally, we're able to achieve almost parity between the three providers. But there are a couple of interesting, if you like, special powers that some of the providers have for some services that might appeal to you more than others as part of your journey. So on this slide, what I've done is I've broken down the permissions hierarchy. So these are the levels at which you're able to apply permissions to objects in the data stores in AWS. So for S3, we have buckets, folders, and objects, and for Redshift, we have fairly traditional database structures where we can apply controls. But AWS has some special features in orthogonal controls, and these are controls that sort of operate outside of the standard hierarchy and independent of the standard hierarchy. And here, AWS, particularly on S3, has some special features that would be familiar to users of mainframe environments. And that is the ability to apply security based on metadata and based on patterns of file names and things like that. They also have some capabilities to prevent requests against S3 unless they come from specific IP addresses or from specific other parts of the AWS environment. In Azure, you'll see that when it comes to Synapse Analytics, we've actually got incredibly granular permissions that we're able to apply, and we're able to do that at the table level, which means that whenever our data is exposed to any other application, provided that we know the user's identity, we can hide the data from the user, or we can control the user's access to specific rows and columns. And so Azure has some, Synapse has some really special capabilities among the cloud databases for doing this. And these are the same facilities that are available inside of SQL Server. And on the GCP side of the house, our permissioning structure works across our storage layer and our database layer in roughly the same way. In fact, there's a strong parity between the notion of a project, a bucket, and an object, and the project, the BigQuery data set. And there's also some new functionality that's been added around controlling access to individual columns in BigQuery. GCP has some special features in data security around contextual-based access control. So you're able to check the properties of, for example, the time of day that you're trying to access particular services, or the IP addresses that you're coming from. You're also able to define that those rules only apply to certain parts of certain services. That those controls only apply to certain parts of certain services at any point in time. Okay. And so really, if we're looking purely through a lens of data security capabilities on object stores, AWS gives you the most flexibility and the most options. And for cloud databases, or at least for the cloud database, Synapse Analytics provides you the most comprehensive, out-of-the-box set of security controls. So this is one of those situations where you might want to start looking at, what your needs are, and make your decisions based on how you're going to be presenting your data. On this next slide, I want to talk about the administrative experience on cloud. And what I mean by the administrative experience is, what are cloud operators day to day? How are they experiencing the system? What kind of flexibility are we given? And look at the pricing model and also the technical support packages. And here we've gone and done some homework and rated each of these based on our view and our experience of having worked with all three of these platforms. So when it comes to administration, and when you're looking for administrative flexibility, so this is the kinds of controls that you can apply in places, the kinds of automations that you can put in place. Really, AWS leads the pack, not by a lot, but it certainly provides the most comprehensive set of controls over cloud resources. So it gives you an enormous flexibility. In terms of simplicity of the administrative layer, though, and this can be really important for clients that are just moving to the cloud, GCP actually wins out. It has a much easier set of permissions and a much easier methodology of and consistency in the way that permissions are applied across the environment. But then in terms of support, which is if you were to get on the phone and call the vendor and get them to walk through an issue with you, AWS leads the pack by a long shot. In terms of pricing models, and here we're talking about pricing models overall, so this is not specific to data analytics. This is looking across sort of a much broader view of all services. In terms of the flexibility of the pricing models that are available, Azure leads the pack, and the reason for that is twofold. Firstly, Azure is very big on bring your own license. So if you've made significant Microsoft investments in the past, as a lot of companies have, many of those license agreements can be honored inside of the Azure cloud, and that includes some of the broader enterprise licenses that a lot of clients might have. Azure also has some pricing that's specific to large enterprises and sort of enabling large enterprises to leverage Azure cloud that are fairly unique compared to AWS and Google Cloud. Although, you know, if you talk to each vendor, they're going to compete against each other. In terms of simplicity of pricing model, though, Google Cloud really comes out on top. And the reason for that is that Google's pricing across its services are again, very consistent, very simple, and very easy to understand. And this is one of the differentiators that Google often puts forward. Unfortunately for Azure, it's actually a pretty complicated situation. So with all of the flexibility that you get from Azure's pricing model, you get some, you don't end up with a particularly simple picture of it at the end of the day when you're trying to break down costs and reallocate those to cost centers, which can be important for a lot of enterprises. And then finally on support, AWS again is the winner. Their administrative support in our experience is really outclasses Azure and Google Cloud. And then finally, in terms of the availability of support packages, we tend to think that AWS has the best offering here. Both in terms of the flexibility, so the different packages that are available for purchasing support options, and the simplicity of accessing those options, but also the quality of the support that you get at the end of the day. AWS have done a lot of work in that domain, and that makes them really stand out. And so that brings us to the presentation, to the end of the presentation part of the webinar. We'd now like to open the floor up for questions.
I do want to say before we dive into questions, I just want to add that what most people are probably the burning question, I'll just attack it head on, is when you're doing your success criteria and your decision making, you're probably thinking, well, in some cases, it looks like Azure might be the winner. In some cases, it looks like GCP might be the winner. In some cases, it looks like AWS might be the winner. That is true. It is true quite often, actually. And also, in some cases, it might be like staying on-prem might be the winner. So in our next webinar, which is forthcoming, we will attack those two things head on. So one is, what does a multi-cloud solution look like? And what does a hybrid cloud solution look like? Obviously, multi-cloud is when you're using more than one vendor for the overall platform. And then hybrid is where you're having some on the cloud and some on-prem. And how do you use data, get usage across two different environments?
All right. Thank you, Joe. And now we're going to move on to Q&A. So in the questions panel on the right, you can ask your questions, and we will get started. So the first question we have is, how would technology stacks and COTS products, commercial off-the-shelf products, play into deciding a cloud provider? I'm assuming that means existing technology stacks.
I'm sorry, ask the question again.
How would existing technology stacks and commercial off-the-shelf products play into deciding a cloud provider?
Maybe, is this a compatibility question, maybe? Right. So, like, if you want to move Oracle, you cannot move Oracle to GCP, right? You need to have AWS in order to run Oracle. If you have SQL Server, you could run it on any of the above, right? I think that might be the type of question you're asking. It does come into play. It is one of the considerations. Compatibility with existing tech debt is definitely something that needs to be considered. Also, enriching existing platforms with third-party solutions may be a consideration as well. For example, if you have love and affection for Snowflake, Snowflake runs on Azure and AWS, does not run on GCP, at least not yet. So these are considerations that should be added to your ranked weighted success criteria.
Joe, I'll just tag on the end there.
Sure.
If the question is specifically about, and this can be a concern for a lot of Microsoft shops, that because I use .NET, because all of my infrastructure is Windows based, does that make Azure the natural place that I should go and look, or the only place that I can go and look? And the answer to that is no. There's broad support for .NET across all three of the providers. So the cloud native APIs all have libraries for .NET, so that .NET programs are able to access those services. All three providers also provide Windows containers and Windows instances that you're able to deploy your existing applications to, and any new applications that you develop in .NET.
All right. Did you want to add something to that, Joe?
No, I skipped a very obvious thing when I was using the Oracle example. That Oracle Cloud could also be a solution if you're running Oracle software.
That's right.
And indeed,
so here's
on that, we actually find that a lot of our customers that have large Oracle installations are the first clients that are starting to look into multi-cloud solutions so that they can keep their existing Oracle ERP installations up and running, but take advantage of some of the capabilities that are available on other clouds.
All right, thanks. Our next question is, can you share any insights on Snowflake versus Redshift versus Synapse versus BigQuery? That also might be good for our next webinar in the two-part series. That's a much deeper question. Joe, do you want to chime in?
No, I'll say that we both immediately smiled, because that is, first of all, that's the part that makes both of our propellers spin, right? Because it's databases, and that is really at the end of the day, that's really the part that matters most when you're doing data solutions. But I do think that having a compare and contrast specifically against those with Snowflake, I think is something that we should put in the next webinar, because it doesn't deserve, I mean, it deserves more than like a 30-second answer. It deserves a full segment of a webinar.
All right, so we will follow up with that, David, in a subsequent webinar. You can email me and we can discuss it if you have a pressing question about it. Our next question is...
I will add, we do have strong opinions in that area, so it's going to be an exciting webinar. And I will say one other thing, that in the next webinar, we're going to have different, because it's going to be more than just Brent and I, if I even attend, I'm not sure yet, but we're going to have specific Caserta consultants defending each one of the clouds. So it's going to be an exciting debate.
All right, we have a pricing question now. What can you share about insights into the total cost of ownership between AWS, GCP, and Azure? Do you have that info?
It's going to be use case specific, and so there's no easy answer to the question. We can, in broad brushstrokes, say that for compute in general, GCP and Azure come out a bit cheaper than AWS. We can also say on the storage side that in general, or at least the sticker price for S3 services is generally a bit lower than the other two providers, but there are some performance trade-offs compared with the other providers. However, the differences here are quite small.
Yeah,
you know,
There is actually, we'll add this to the next webinar too. It varies depending on use case, and use case varies depending on the functional capabilities that are required. For example, if you are storing lots and lots and lots of data but not querying it often, versus you don't have that much data but you have highly complex queries and high user concurrency, those are two very different usage patterns that would make very, very important variables to consider when you're deciding, when you're trying to estimate the cost of one platform versus the other. And we will go through that in the next webinar.
All right, I think this might be our last question. So anyone else that we haven't answered, please feel free to email me. I'll be reaching out to you and you could just reply to the email that I send. How can you guys characterize how quickly each platform is evolving, and could a 3 or even 6 month time frame materially alter this type of cloud vendor evaluation? That's a good question.
So I think that the standout in terms of development in the past 12 months has probably been Azure. So the pace at which its services have improved is really quite breathtaking. I think also Microsoft's broader focus on open source and embrace of the backbone of the cloud, which is really Linux-based systems, is reflected in a lot of the decisions that Microsoft have made about the specific services that they've chosen to develop. It'll be exciting to see which vendor tries to take Microsoft on directly in the areas that Microsoft has chosen to compete. But this is the beauty of competition.
Yeah, I'll add that, because we come from the data warehousing and BI world, years ago when it was BI tools, right? There were basically 3 main BI tools that anybody ever spoke about: Cognos, Business Objects, MicroStrategy. And depending on what year it was, right, they constantly leapfrogged each other as far as like their advanced capabilities. One year one was better, one year the other was better. I will say that, 3 years ago, we were almost exclusively AWS with some GCP as far as our client base. 2 years ago and some of last year, we were primarily GCP because it had just has come out of the gates and really advanced a lot of its features in the last couple of years. And towards the end of last year and into this year, we are seeing Azure really come on strong. So like Brent was saying, competition is good. We are starting to see that leapfrog effect. And a year from now, the opinion might be different from what it is today.
I think though that for people on this call, don't think that 6 months is going to change your world fundamentally. It's really not. When new functionality appears on one cloud, it's usually a signal or only a matter of time until equivalent functionality appears on the other cloud. So a really good example of this would be, as I've waxed lyrical on so far in this presentation, a lot of the security controls that are available in the Microsoft stack for Synapse. They're finding their way into both BigQuery's offering. So BigQuery has, Google's BigQuery, which enables column level controls that are based on metadata rather than an ACL on the column, which is a really interesting approach. But also, if you read between the lines of their documentation, there are statements like, row level controls are not available on this service as yet, right? So all of the services are leaving themselves room to introduce new capabilities to solve the problems that their clients are coming to, or the capabilities that their clients are coming to and asking for, but they're also looking at the deals that they lose because they don't have specific capability and building out in response to that.
We are on top of the hour, so.
Yes, we are. Everyone, thank you very much for coming to today's webinar, and we will send you the recording. And if you have any questions about migrating to the cloud or re-architecting for the cloud, you know how to contact us. Thank you so much, and I'll see you at the next webinar. Thank you, guys.
Thanks, Jeremy.